So today we're going to be talking about special right triangles. Now there's two types of special right triangles. There's a 30, 60, 90 degree triangle and a 45, 45, 90 degree triangle. As you can see, it's getting its name from the degree measures of the actual triangle. So we're going to start by talking about our 30, 60, 90 degree triangle. I'm just going to fold this so we don't see the other one. Okay, so 30, 60, 90 degree triangle. So with this, where first off a 30, 60, 90 degree triangle is coming from is it is coming from the thought of this equilateral triangle, or of an equilateral. It is not equilateral, but it's coming from, this is going to be half of it. So if I take an equilateral triangle, that means all of the sides are congruent. All the angles are going to be congruent, therefore making each angle 60 degrees. Okay? And so what we can do is we can split the triangle in half. And so what you're seeing here in this picture is just half of that equilateral triangle. When I split down the middle, I'm bisecting the side here, and I am bisecting the angle that was 60 degrees. So that's very difficult to see, sorry. It is now 30 degrees here. Okay, so I'm going to give this side here a length of 2. Okay, now since this yellow line is bisecting this equilateral side here, or this side, that equilateral triangle, so this is 2, if it bisects it, that means from here to here, this is 1. And so if I needed to find the height of this triangle, okay, this is making 90 degrees, so the height of the triangle, I could, going from past courses, use Pythagorean theorem. So in doing that, I would do 1 squared plus h squared equals my hypotenuse, 2 squared. So solving this, I am going to get that h squared is equal to 3. And so to get the variable of h by itself, I'm going to take the square root of both sides, and so h is going to equal the square root of 3. Remember, we like our answers as exact as possible. Sorry. Okay, so what this leads us to is this actually leads us to what is the ratio between the sides, the relationship between the sides of the triangle and the angles of our 30, 60, 90 degree triangle. So I like to do this as kind of making this table. So we have 30, 60, 90 degrees. And so since 30 degrees is our shortest or our smallest angle, across from our smallest angle, from our inequalities we know, has to be our short side. Okay, so our short leg gets our n. Across from our 60 degree angle is our long leg. And in this case, we're going to give it a ratio of n times radical 3. And so again, that's coming from when we did Pythagorean theorem over here. We're able to get that radical 3. So where'd the n go? Because this is just radical 3. The n is because here we were using this value of 1. So imagine the 1 there. This is 1 times radical 3. So it's going to be n, our short leg, times radical 3. And then finally, we have our 90 degree, and across from our 90 degree is our side that is going to be 2n. So again, remember we split an equilateral triangle in half. And remember that this is our hypotenuse. Okay, so we have a 30, 60, 90 degree triangle. Our ratio between the sides and angles, or with our sides, is n to n radical 3 to 2n. Now I like to put into words sometimes, what does this mean? So in referencing to our short leg, our long leg, so our long leg is the short leg times the square root of 3. Okay, so again, verbalizing it. The hypotenuse is double the short leg. Okay, so we have, again, short leg is our n, long leg is the short leg times radical 3, and the hypotenuse is double the short leg, or 2 times that. So let's take a look at a few examples. So I'm going to have a triangle. I'm going to have an angle of 30 degrees up there. I'm going to have side lengths of x, 15, and y. So again, if I make this little table like a tic-tac-toe, I always am going to start with, because this is a 30, 60, 90, I'm going to start with 30, 60, 90, so the angle is on top. I'm going to then in the middle put the ratios that I know, so n root 3, and 2n. So again, we talked about those. And then I'm going to start filling in with what information do I know from my picture. So the 30 degrees is here. Across from the 30 degrees, this is my short leg. And our short leg is 15. Across from our 60 degrees, which it's not here, but our long leg is going to be our variable of x, and then across from our hypotenuse is going to be y. And so with this problem, what I know is that n is equal to 15. So if n is equal to 15, the best thing to do is remember that the hypotenuse is double the short leg. So that now makes y is going to be double 15, so 30. Our long leg is the short leg times radical 3, so x is going to be the short leg, which is 15, times radical 3. When we're doing special right triangles, we want to stay away from doing trig using sine, cosine, or tangent, because we want to be able to get our answers in exact form, not approximate form. Let's go ahead and go on to a second example. If I have a triangle, a right triangle, we're going to have 8 as our hypotenuse. We'll put our 30 degrees right there. And we have sides of x and y. So again, my starting point, a 30, 60, 90 is in the ratio of n root 3 to 2n. What information do I know about this problem? Well, across from my 90 degrees is my value of 8. So this is my hypotenuse. Across from my 30 degrees is the variable for y, and then that leaves x across from my 60. So what information do I know? Well, I know that 2n is equal to 8. So in this problem, I'm going backwards and I need to find out what n is. So to get n by itself, I would find that n, I would divide by 2, so I'd find that n is equal to 4. Okay, I need to know what n is, but in the end, this is that. So that means that since n is equal to y equals 4. Because our short leg is half of our hypotenuse. And now that leaves us with our long leg. Our long leg is the short leg, which happens to be 4 times root 3. So I have that x is equal to 4 times radical 3, and y is equal to 4. Okay, let's go on to another one. I'm going to take this another step further. We're going to have, let's go with 30 degrees, 60 down here. We're going to go ahead and make this side length 9. We're going to go ahead, I don't know, M and N. Okay. What are we going to start with? Our table, 30, 60, 90, N, and radical 3, 2N. Okay, so what information do I know from my picture? I know that across from the 60 degrees is my numerical value of 9. Across from my 90 degrees, so my hypotenuse, is, oh, I shouldn't have used N here, so let's change this. Let's make this P. Okay, so across from that 90 degrees is my variable P, and that leaves me with, across from my 30 degrees, M here. Okay, this is a 9. Make sure we know that. Okay, so information I know. I know that n radical 3 is equal to 9. Okay, so there's my starting point. I need to actually kind of work backwards on this one to find out what does n equal. So by dividing by the square root of 3, I can find that n is equal to, let me switch colors here, that one's dying. N is equal to 9 divided by the square root of 3. Now, this is an acceptable answer. However, if you're going on to higher math classes, we don't like a radical 3 in the bottom. We don't like a radical or a square root in the denominator of a fraction. So to change this around and get an equivalent expression, it's called rationalizing. And so what we can do is we multiply by whatever we have in that radical on the bottom. So I can take 9 divided by radical 3 and I can times it by radical 3 divided by radical 3. So multiply across, we get 9 root 3 over, well, the square root of 3 times the square root of 3 is, 3 times 3 is 9, and the square root of 9 is 3. And so that's how we're getting that radical or that square root out of there. And then I can take this one step further because 9 over 3 reduces, and I get 3 times the square root of 3. So again, 9 divided by the square root of 3 is an acceptable answer. However, many of you should get used to using 3 times the square root of 3, converting that, simplifying it. Okay, so what was that? That is our value of n. So that really is saying that m is going to equal 3 root 3. Okay? And then our hypotenuse is going to be double this. So that means we will be doubling it. It's going to give us 6 root 3. Okay, so again, just kind of reminder mathematically, 2n, and if that is 2 times 3 radical 3, I can only multiply these two together. I'm not multiplying also times that radical 3. That's not what we do with that operation. So hopefully this helps you understand 30, 60, 90s. Write down any questions that you have, and we can take a look at them when we come back together.